Good morning. Today we will present our automaton project with a South Korea theme, more specifically, the musical instrument gayageum. The team members are Brian Tolosa, Andres Cuellar, Juan Bautista, Christian Valderrama, and Ivan Romero. This is for the course on motion engineering and/or mechanisms, taught by Professor Miguel Montoya. Content: we will start with a brief introduction, a description of the movements, and a mechanical characterization, the manufacturing of the components, and, finally, the working prototype. Introduction. The gayageum is a traditional Korean string instrument, similar to a zither, which typically has between 12 and 25 strings. Originating from the kingdom of Gaya around the 6th century, it is one of the most iconic instruments in Korean music.
The characterization of the movements. We will have three movements, the first being the displacement of the head, which will be carried out in a displacement between two angles with respect to the z-axis. As a second movement, a displacement of the right arm, which occurs on the x-axis, which will simulate that the instrument is being played. A displacement of the door, which will move horizontally on the y-axis, generating a movement of opening and closing of said door. Mechanical characterization. For the cam follower set, here we have the follower diagram, as well as the time and displacements in the ascent, descent, and stop. These displacements were found using the harmonic motion formula.
For toothed wheels and transmission systems. For the Da Vinci type gears, an outer diameter of 60 mm, 8 pins and 48 mm in diameter of the pitch circle were used. For the reduction of the motor to shaft, two gears were used, one with a diameter of 20 mm and the other with a diameter of 80, giving us a ratio of 4:1. The engine gives us 200 RPMs, and with this ratio it finally delivered 50 RPMs on the central axis. The pulleys of the music box. There were two pulleys, an entry pulley with 46 of 45 mm and an output pulley of 25 mm. The axle, as we mentioned earlier, was delivering 50 RPMs. Since the 4-bar mechanism, we find two revolutes and two revolute joints and a prismatic joint, as well as the dimensions of the links. Laser cutting was used for the manufacture of the components, for the boxes and gears. For the axles and doors, the 3D PLA printing was used, and for the character, the 3D printing with resin was used.
The working prototype. For the head movement, which we mentioned earlier, you can see how we managed to get this movement between two angles, just like the movement of the right arm, where you can see how it moves as if it were playing the instrument. And for the third movement, which was the one for the door, you can see that we did manage to simulate opening and closing that door. Finally, the video, showing the prototype's final operation. Thank you.